Today we begin our study of functions. We'll be looking at section 3.1 of the book. And the title of this section is Functions and Function Notation. So there's three main ideas that we're really going to be covering today, and we're going to break this off into three different sections. So in the first section, which I'm going to title Section A, we're going to define a function in terms of a relation, and then we're going to see how to determine when a relation is a function. And I'm just going to title this section Definition of a Function. In the second section, we're going to be seeing how to find input and output values of functions, and the title of this section is going to be Input-Output Values. And then finally, in the last section, titled Part C, we're going to introduce a special type of function called one-to-one functions. And then we're going to introduce some useful tools that are going to allow us to determine if a relation is a function and if a given function is one-to-one. And so let me just go ahead and title this section the horizontal and vertical line test, or comma vertical line test. So throughout this lecture, I'm going to assume that you know how to graph a function from previous experiences, but remember, if there's anything that you want me to address, just ask me. Before we look at any of these sections, let's go ahead and draw some pictures that express the idea of what a function really is. So before we draw pictures, let's have an ad hoc definition of a function. So intuitively, we're going to think of a function again as the following. A function is going to consist of two things. It's going to have a set of inputs and a set of outputs, where each input is sent to only one output. With this definition in mind, let's go ahead and draw some pictures. Assume that P, Q, R, M, and N are real numbers. In this first scenario, let P, Q, and R be our inputs, and let M and N be our outputs. Where we have that P is assigned to M, Q is assigned to N, and R is also assigned to N. So this picture is an example of a function. And the reason why this is a function is because each input is assigned to only one output. This means that each input has only one arrow emanating from it to an output. Now let's go ahead and look at another scenario. Again, suppose that we have P, Q, and R are our input values. And again, we have M and N as our output values. Again, suppose that P is assigned to M, Q is assigned to N, and R is assigned to N, but then suppose that we also have P is also assigned to N here. So this is an example of something that is not a function. Again, the reason why this is not a function is because an output has an arrow that's has multiple arrows emanating from it. In this case, P is assigned to M and P is also assigned to N. This breaks our definition of a function, as inputs can only have one assignment. So let's go ahead and draw one more picture. So again, suppose our inputs are P, Q, and R. And again, suppose our outputs are M, N, but then we have a new output. Let's call it S. Again, we have that P is going to be assigned to M, Q, let's say, is now assigned to S, and R is still assigned to N. So by the logic of the first example, this is in fact a function because each input is assigned only one output. But this is a special function. This is an example of a one-to-one function. And the reason why this is a special function is because every assignment of an input value to an output value is unique. So this concludes our example on the intuition of a function. One thing to note is that we're going to be working with functions that have infinite inputs and infinite outputs, but in the previous example, our function only had a finite number of inputs and a finite number of outputs.